Hello ladies and gentlemen, welcome back to C.A.R. Entertainment. I'm your host Dylan Hamilton, and today we're going to be talking about gene interaction as our final video as a part of our inheritance section in our AT2 biology and religion videos. Without further ado, we're going to go straight into it because gene interaction involves two simple things, which is epistasis and polygenic inheritance. Polygenic inheritance is very short, epistasis is a little bit more in depth, and we're going to go through those two right now. So, what is epistasis? Well, this is whenever one gene will mask or suppress the action of another gene, and these are commonly called inhibiting genes. So, if you inherit two genes, one gene's goes through epistasis, then that gene will suppress the other gene, meaning the other gene will not actually express itself. So, let's talk about pure breeding within mice. So if a mice has a big A, then it's a guty. If it has a small a, then it's black. If it has the M, then it shows the pigment, but if it has the small m, then it has no pigment. Okay? So pure breeding, a homozygous agouti with a homozygous albino. An albino is one that has no pigment. So the phenotype is agouti versus albino. And because we're pure breeding, that means it must have the double homozygous dominant and the double homozygous recessive. So the genotype is going to be AAMM, all capitals, versus AAMM, all lowercase. So the gametes are going to be capital A, capital M, capital A, capital M, versus small a, small m, small a, small m. The phenotypes will be all agouti, and the genotypes will be all big A, big M, small m. And the reason for that is by the table above. You cross a big A and a big M with a small a and a small m, you're going to get a big A, big M, small m. And that's going to be the same all right. So what if we cross their offspring then? What if we cross a big M, small m versus the same thing? Well, the phenotypes will be agouti versus agouti, and the gametes will be a big A and a big M versus a big A and a small a and a big M versus a big A and a small m. Or sorry, that should be the other way around. That should be we should have a big A, big M, big A, small a, big M, and then a small a and a small m. And that should be the same way throughout. So eventually you will get 9384 within this here, because you're going to get 9 agouti, 3 black, and 4 albino with their genotype stated there. And the reason for it is if you look up at the table, that's when you cross. You cross two, you cross big A, big M with big A, big M. You're going to get 2 big A's and 2 big M's, and so on. You go through the table. You can pause the video and look at that. So what if we use combs in fowl, which is a type of animal? Well, if we go through the comb P versus rose, then the genotype will be capital P, small r versus 2 small p's, a big R, and a small r. So the gametes will be capital P, small r versus capital P, small r versus small p, small r. So if we go through and we cross that, then we're going to get the genotypes of capital P, big R, capital P, small r, 2 small p's, big R, small r, and then small p's and small r's, which means the phenotypes we will receive will be 1 walnut, 1 rose, 1 pea, and 1 single. So as you see from the top table up there, all the different comb types, what genotypes respond to what, and the explanation. So for example, a walnut will mean you will have at least 1 dominant P, and you will have a dominant R as well. So you'll have at least a dominant P and 1 dominant R. You'll have at least one of each. The P, you'll have at least 1 dominant P, but you will not have a dominant R. You cannot have that dominant R, but you have to have a dominant P. In rose, it's the other way around. You have to have a dominant R, but you can't have a dominant P. In single, you just have both homozygous recessive. In flower color, you basically go through the same thing as you see up there in the top right. There's the Punnett square for it. 2 genes will have at least 1 of each being dominant. Then it will be purple. So a capital C and a capital P, for example, you have both of those, then you'll be purple. If only 1 gene is dominant, you'll be white. So for example, if you only have a capital C, or if you only have a capital P, or if you have neither. So if we cross purple versus purple, which we have done there in the Punnett square available, then you'll get 9 purple and 7 white. The gametes are shown there as well. So if at least 1 dominant allele is in each gene, then it will make the gene functional. But if either gene is homozygous recessive, an enzyme will not be produced and a metabolic pathway will not be completed. So finally, we'll finish up with some polygenic inheritance, which is much shorter than epistasis, like I've said. Well, polygenic inheritance features polygenic, which is determined by many genes acting together, and these are found at different loci. These have a cumulative effect on the phenotype. So, for example, a range of height is continuous variation, and discontinuous variation is controlled by a single gene. Thank you for watching the video. I've been Dylan Hamilton from C.A.R Entertainment, and I'll see you next time.